Up until today, when you only had X and Y, we could simply use elimination, substitution, solve this really quickly. It's like a 2, maybe 3-step tops thing. Then you are done and you move on to the next one. The second we add in that third variable Z, things start to get a lot more complicated. So this is a great, just little like, it's a pre-lesson moving in. That's really loud. It's a pre-lesson moving into working with matrices. Okay, so these look super complicated. They look really gross. We can use our same elimination processes from yesterday, just like times 10, to be able to solve these down. In the end, after doing all of this, we should end up looking like what I have over here. So this is the end goal. What we call this, and let me move you guys over. What we call this is row echelon form. And I'll write that down for you. It looks as weird as it sounds, but it is called row echelon form. This is more specific to using a matrix. In a matrix, you would actually be able to see every single row and every single column, and you'd see that it all files down diagonally, so pretty. 2 things for row echelon form. When you get down to this very bottom, you should have an actual value for your Z. If you have still like a Z plus X or 2Y plus C, you're not in echelon form yet. So you should have your Z absolutely solved for in row echelon form. Also, every coefficient to these, the leading coefficient should be 1 when working in row echelon form. When we're not using a matrix Z, we don't specifically have to have it solved down to a, that is so loud. I've never heard it that loud before. I'm so sorry. You don't specifically have to have it as a leading coefficient of 1 all the time. It's going to make your life 10 times easier if you do. Sometimes it happens naturally. Sometimes we force it to happen. There will be situations though where you don't have to get it that simplified. So the steps from here to get to there are a lot. So this was where yesterday I kept saying, like, in the future, when we are doing these, if you make one mistake, you're going to screw yourself up for the entire time. So if we went to do elimination and you added 9 plus -2 wrong and got 11 instead of 7, you're instantly right off the bat going to get the wrong answer in the end. And it's likely going to not work out for you very well. And you're likely going to end up with some really gross fractions. And it's not going to be pretty. So rule number 1, when we're working with these, is you have to be really careful. Like, don't speed up through these. If you have to check yourself with a calculator, like, hurt my soul and do it, it's fine. But just slow yourself down. The reason you make mistakes by adding 9 plus -2 and making it 11 is just because you're going too quickly. So first thing is slow down. The second thing is just be careful. Because the last thing I want you to do is get through 15 minutes of this and not get the right answer in the end. Because then you have to go back 5 steps and redo it all. And you'll hate yourself for doing that. Okay, hopefully we get through this entire example today. This will probably be the only one we get through today. Okay, but I'm going to try to stay slow and make sure that you're following along with me. I'm not going to lie. This might be one of the more frustrating processes. You might not be quite as pissed off as with trig, but it's just a long process to get through. We'll be like 15 steps deep by the end. Okay. So I am going to label these equation 1, 2, and 3 so I can talk about them as if they're 1, 2, and 3. And the process we'll be using is called Gaussian elimination. In case you're curious, that is the official name of it, Gaussian elimination. So when I'm looking at this to begin with, I know that my end goal is over there. I'm trying to get down to just having a Z. So I start off by just trying to simplify and eliminate variables, okay? Keep in mind, we have an XYZ, an XYZ, and an XYZ in all 3 equations here. Over in the very ending spots, I only have 3 variables in my top equation, then 2, and then 1. So we somehow have to start eliminating variables away. So a good start to that would be if I have any natural eliminations, I want to use them. So the first thing that I see when looking at equation 1 and equation 2 is if I specifically worked with these two equations at once, I could eliminate my x's. Okay, I have a positive x and a negative x. If I did my elimination with just those two, I would eliminate down and be down to just no x's. Okay, so I'm going to write a little thing over here to the side, and I'm going to take equation 1 and add it to equation 2. So I'm going to do some of this work off to the side and then bring it back to my what I have now. So if I added 1 and 2, as they are now, without changing anything, without multiplying by anything, these two would cancel. I'm going to have no x's left. Over here, negative 2y plus 3y, I'm going to be left with just a y. Then I come over and I add my z's. I have 3z plus z to give me 4z, and I really shouldn't put an equal sign here. I'm going to put an arrow. And then over on my equal sign, 9 plus negative 2 gives me 7. Okay, and that is going to be my new 2. So I use all these arrows to describe what's happening and all these different notations. So I took 1 and 2 and I added them to get the new equation that's going into replace 2. The reason I keep saying replacing is because sometimes we don't replace. Okay, so now what do I have? Out of equation 1, 2, and 3, I still have my original equation for number 1, x minus 2y plus 3z equals 9. I still have my original equation 3, which is 2x minus 5y plus 5z. Did I write that one down right? Okay, good. Nope, we're good. Sorry, I did not know I had 2 5's in there. It'll still work out good. Okay, equals 17. The only thing I replaced was my equation 2. So this is my new equation 2. I did that elimination process in order to get a new equation 2. My new one is y plus 4z equals 7. All right. So two confusing things here that a lot of people have a pitfall in. A lot of people don't understand how we could combine these two and only now replace my 2. So a lot of times people forget to revert back to that original 1. Also, people forget to bring through that original 3. We didn't do anything with it. We didn't touch it. We're just continuing that one on. Okay, so we've gotten one thing done. And if you can kind of see, this is my end goal. I've already gotten that middle one accomplished. So I'm one step ahead now. But now I still have this 2x and this negative 5y that I just need completely gone in order for me to get back into row echelon form. Okay, so take 30 seconds. I'm not going to make you write anything down, but I want to help you start to make choices as to what to do next. So take 30 seconds to decide if you were trying to do some elimination here, what would you choose to eliminate and how? Remember, you can multiply a row by something, you can divide a row by something, but you can use either 1, 2, and 3 in groups of 2 to try to eliminate something next. So take 30 seconds to just try to do that. Nothing else, you don't have to write it down, just try to make a choice as to what you're going to do next. Maybe talk about it with somebody. These are tough. The more I try to push you earlier, the better off you will be. Yeah, go ahead. Okay, so what your idea is might be different than mine, and there's always multiple ways to go about this. I'm going to take you on my direction. If you like your direction, keep going with it, that's fine. So what I'm going to choose to do is we work our way in from left to right. So I know the next thing I need to get rid of is this 2x. It is harder to eliminate a y and then get rid of an x than to just work your way in from left to right. So in order to negate this 2x, I have to have a negative 2x to add it to. There's nothing in equation 2 for me to cancel out with, so I can't use equation 2. So I'm focusing solely on equation 1 and equation 3. Okay? So if we erase this one, and yesterday I said, how do I eliminate, or how do I use elimination to get rid of my x's? You would hopefully say, for one, I have a positive x and a positive x. So I know whatever I multiply in, I have to introduce a negative. Second thing, I have an x and a 2x. So somehow I have to bring in a 2 to also cancel this out with. So what we're going to do is take equation 1 and multiply it by negative 2. Once that's done, then I will add it to equation 3 to get a new 3. Okay, so my notation is I'm multiplying 1 by negative 2 first, adding to 3, arrow over to get a new 3. Okay, so let's do that multiplication off to the side. If I multiply this whole thing by negative 2, I would have negative 2x times positive 4y times negative 6z times negative 18. And if I do any of these wrong, please speak up, because I don't want to also mess you guys up. There's a good chance I might add or multiply wrong. It happens all the time. Okay, so I've multiplied by my negative 2. So now I get to add to my equation 3. I like to do all my work off to the side so I don't interrupt all my nice, lovely equations here. Adding on to 3, my 3 is positive 2x, negative 5y, plus 5z equals 17. Okay, so we're going to add straight down then. And again, remember, the goal is to obtain a new equation 3. Negative 2x, positive 2x. Those are canceling. Positive 4y, negative 5y. I'm left with negative y. Negative 6z, positive 5z, negative z equals negative 18, positive 17, negative 1. And again, that was my new 3. So if we start a new line over here for my, I'm going to erase this work. My next new equations for 1, 2, and 3. I did not change 2, so that's staying y plus 4z equals 7. My new equation 3 is down here, negative y minus z equals negative 1. And I did not obtain a new equation 1. I used a different form of it to cancel out with 3. But every single time you multiply by something, it's still equivalent to its original equation. So I used it to manipulate something, but I always revert back to my original unless I specified otherwise. So my equation 1 is still x minus 2y plus 3z equals 9. Okay, questions there? I know you're lost, that's okay. Like, sit comfortably in the confusion, it's okay. It's gonna be hard at first. So first question, do you understand that we reversed back to our original 1? We did not change it even though we used a version that was multiplied by negative 2 over here. We went back to our original 1. Okay, kept 2, had to change to our new 3 that we got over here. All right, so how much further did we get though? We now have only one x, which is exactly what we want. We do still have 3 y's. We need to get down to just 2. So that's the next thing we're going to work on. The next thing is to try to eliminate this y in my equation 3. So take 30 more seconds. Try to decide how would you do that? What would maybe even would your notation look like? I'm not big on notation. It just helps me to keep my math and my working track. But what would you do next that would take you one step further to be closer to our end game? Okay, 30 seconds. Just try it. How would you use elimination? Okay, this was a little bit easier one. Since I already have a positive y and a negative y in my equation 2 and 3, I'm going to use that. But let me also reiterate, I would not want to use equation 1, right? If I added equation 1 to equation 3, you bring an x back in. I would not be able to get rid of this x, and I'd bring it back in, and you would just reverse everything you just did to get rid of that x. So I solely want to focus on 2 and 3. Those are the only ones without x's, so it's going to get me one step further towards getting down to just z. So I don't have to do anything to this one. I can simply just add right away and cancel those out. So I'm going to take equation 2 plus equation 3 to get a new 3. Okay, that arrow over means obtain a new 3. If you add those two together, y plus y is 0. 4z minus z would be 3z equals 7 plus negative 1, which is 6. And again, this is my new 3. So write our next step. 1, 2, 3. My equation 1, I didn't even touch it, so it, of course it stayed the same. It's still x minus 2y plus 3z equals 9. Equation 2 I used, but I didn't change it. So it's still y plus 4z equals 7. My third equation is here. It's a new one. 3z equals 6. Okay. So we're almost there. One important note is that you can manipulate just one equation at a time. So this time, to get this into reduced row echelon form, I want this to be a coefficient of 1. So I have to divide by 3. So I'm going to take equation 3. I like to multiply by fractions instead. So I'm going to multiply by 1/3. You can take equation 3 and divide it by 3. That's fine. For matrices purposes, I do multiplication by fractions. Okay. So finally, if we did that, you would be looking over at what we wanted our end goal to be, right? Equation 1, 2, and 3. That's what we wanted. Okay. Did I solve it though? Do I have an XYZ solution? No, I didn't. It's the worst. All right. So now you can see, why did we want to solve down to reduced row echelon form? Why did we need it down here? So in the very, very, very beginning, even if I had solved for X, Y, or Z, I still would have everything in terms of 2 variables. Now that I have each of these equations, now that I have a Z solution, I can plug 2 back into equation 2 for Z to get my Y formula or my Y solution. Once I have my Y and my Z, I can plug that back in to equation 1 to get my X solution. So you have to now work your way backwards to find Z, Y, and X. Are you ready to do that? I know we're not done. I'm so sorry. I wish I could tell you we're done, but we're not done. Oh, we have like 3 minutes left, okay? If you want, work on this on your own. You totally can do it at this point. You have the substitution skills to make it back from here, okay? Last couple steps again are just finding my x, y, and my z. My z equals 2. That was easy and awesome. Thank God. To find my y, take equation 2. Y plus 4. Substitute in 2 for z equals 7. If you solve that down, y plus 8 equals 7, or y equals -1. So I have my z, I have my y. Take equation 1 to go and find your x. So x minus 2 times -1 plus 3 times 2, I'm putting that in for my z, equals 9. Solve this down. X, -2 times -1 is a +2. 3 times 2 is 6, equals 9. X plus 8 equals 9, or x equals 1. As a coordinate pair, last stupid thing, kind of just notationally, if you ever saw this on an SAT. Coordinate pairs go x, y, z. So in this case, we would have 1, -1, 2. How many of you hated this more than anything you ever hated before? All right, that's not as many as okay. Okay, it gets better, I promise. We will spend a lot of time practicing this.